Welcome to sureshbhattclasses. We are learning quantitative aptitude topic logarithm. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, RRB, Bank PO, Railways and many government job exams and job interviews. These topics of quantitative aptitude are also useful for many entrance exams like GRE, GMAT, CAT, SAT, ACT and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are learning basics of logarithm. Before starting this topic, I request you to please like, share and don't forget to subscribe this channel. I also request you to please press the bell icon to get the latest notifications. We go to the topic. Point 1. Definition. For a positive real number a, where a is not equal to 1, a raised to power m equal to x, then log x base a equal to m. Here it is read as if a to the exponential power m is equal to x, then logarithm of x base a is equal to m. Log is abbreviation of word logarithm. We learn it with following illustrations. Exponential form, logarithmic form. The exponential form is 2 to the power 4 equal to 16. Then its logarithmic form, log 16 base 2 equal to 4. The exponential form, 3 to the power 5 equal to 243. Then its logarithmic form is log 243 base 3 equal to 5. Exponential form, 5 to the power 3 equal to 125. Then logarithmic form, 125 base 5 equal to 3. Exponential form, 27 to the power 1 over 3 equal to 3. Here 1 over 3 is the exponential form, which is cube root of 27, or 1 over 3 power of 27 equal to 3. Then its logarithmic form is log 3 base 27 equal to 1 upon 3. Here we will learn it by two triangles. In first triangle we move like this, base, power, outcome, and in second triangle we move like this, logarithm to the base equal to power. Logarithm to the base equal to power, and in exponential form we read it as base to the power equal to outcome. Like base is 2, power is 4, outcome is 16. Base is 3, power is 5, outcome is 243. In second triangle, logarithm of 16 base 2 equal to power 4. Logarithm of 243 base 3 equal to power 5. I hope you have understood this definition of logarithm. We can read this as a to the power m equal to x. Then log x base a equal to m. If log x base a equal to m is given, then we can directly conclude that a to the power m equal to x. So we can convert exponential form into logarithmic form and logarithmic form to exponential form. We go to the next point. Point 2. Laws of logarithms. Part 1. Product formula. Log x into y base a equal to log x base a plus log y base a. This formula can be generalized, and the generalization formula is log P into Q into R into S, and this continues, base A equal to log P base A plus log Q base A plus log R base A plus log S base A, and this continues. Now we prove this formula. Let a to the power m equal to x. This gives log x base A equal to m. And let a to the power n equal to y. This gives log y base A equal to n. Now we multiply a to the power m equal to x and a to the power n equal to y, and we get a to the power m multiplied by a to the power n equal to x into y. This gives a to the power m plus n equal to x multiplied by y. Now we apply the definition of logarithm, and we find that log x into y base A equal to m plus n. And we know that the value of m is log x base A and value of n is log y base A. So we put these values of m and n. So this gives us log x into y base A equal to m is equal to log x base A. So we write log x base A plus n is equal to log y base A. This way we have proved the product formula, which is log x into y base A equal to log x base A plus log y base A. We go to the next formula. Part 2, quotient formula. Log x upon y base A equal to log x base A minus log y base A. If base is common, then we can read without base, like log x upon y equal to log x minus log y. Now we prove this formula. Before I prove this formula, I request you to please like, share, and don't forget to subscribe this channel. I also request you to please press the bell icon to get the latest notifications. Let a to the power m equal to x and a to the power n equal to y. Then from the definition of log x base A equal to m and log y base A equal to n. Now if we divide a to the power m equal to x by a to the power n equal to y, then we get a to the power m upon a to the power n equal to x upon y. This gives us a to the power m minus n equal to x upon y. Now we apply the definition of logarithm. As per that definition, log of x divided by y base A equal to m minus n, and we can put the value of m into n. M is log x base A minus n is log y base A. With this we reach to the formula log x upon y base A equal to log x base A minus log y base A. I have understood the formula and its proof. Now we go to the next formula. Part 3. Power formula. Log x to the power n base a equal to n log x base a. Here power comes into product. Before I prove this formula, I request you to please like, share and don't forget to subscribe this channel. Also, please press the bell icon to get the latest notifications. Now we prove the formula. This formula is nothing else but the extension of the product formula. Log x to the power n base a can be written as log base a x into x into x into x n times. This is equal to log x base a plus log x base a plus log x base a n times. This is equal to n times log x base a. This is the extension of product formula, which was formula 1, or which was the first formula, product formula. I erase this and I will prove it with the another method. Let a to the power m equal to x. Then from the definition of the logarithm, log x base a equal to m. Now we increase the power of a to the power m for n times. This is equal to x to the power n. This gives us a to the power n into m equal to x to the power n. And from the definition of the logarithm, we take the log, then log x to the power n base a equal to n into m. And if we put the value of m here, then what we get? N log x base a. This way we can prove the formula. I hope you have understood the formula as well as its proof. We go to the next formula. Fourth formula, reciprocal formula. Log a base b into log b base a equal to 1, or log a base b equal to 1 upon log b base a. Before proving this formula, I request you to please like, share and don't forget to subscribe this channel. I also request you to press the bell icon to get the latest notifications. Now we prove the formula. Let b to the power x equal to a. Then this can also be written as a to the power 1 upon x equal to b. Now we can use these two equations to prove our reciprocal formula. B to the power x equal to a. This gives us log a base b equal to x, and a to the power 1 upon x equal to b. This gives us log b base a equal to 1 upon x. Now if we multiply these two, then what we get? Log a base b into log b base a equal to x multiplied by 1 upon x equal to 1. Also we can write log a base b equal to 1 upon log b base a. I hope you have understood the reciprocal formula and its proof. We go to the next formula. Formula fifth, base change formula. Log a base b equal to log a base c upon log b base c. Here we are changing the base of a to some base c. So to change the base of a from b to c, what we have to do? We have to do log a base c divided by log b base c. This formula is very useful and we will learn its utility while solving the questions on logarithm. We can prove this formula from the example. We know that 10 to the power 2 equal to 100, 10 to the power 4 equal to 10,000 and 100 to the power 2 equal to 10,000. Now we use these three numbers to prove our formula of base change. Log 10,000 to base 100 equal to, from here 100 to the power 2 equal to 10,000. So log 10,000 base 100 equal to 2. Now if we want to change the base of 10,000 to 100, then also it should come to 2 by using the base change formula. So this gives log 10,000 base 10 upon log 100 base 10. This is equal to log 10,000 base 10. We already know that it is equal to 4, and log 100 base 10 equal to 2, and this is again equal to 2. So even after changing the base of this log 10,000 base 100 equal to 2, and on changing the base we get the same value of 2 when we write log 10,000 base 10 upon log 100 base 10, then it comes out to be 2. We go to few useful additional formula. Point 3 additional formula. The first formula is log x base a to the power q equal to 1 upon q log x base a. The second formula is log x to the power p base a to the power q equal to p upon q log x base a. The third formula is log 1 to any base equal to 0. The fourth formula is log a base a equal to 1. And the fifth formula is a to the power log x base a equal to x. Before proving all these formula, I request you to please like, share, and don't forget to subscribe this channel. I also request you to press the bell icon to get the latest notifications. Now we will prove all these formula from examples. 100 to the power 2 equal to 10,000. This gives log 10,000 base 100 equal to 2 from the definition of logarithm. So this is equal to log 10,000, and 100 can be written as 10 to the power 2 equal to 2, and I give this as equation number 1. Now we know that 10 to the power 4 equal to 10,000, and from the definition of logarithm, log 10,000 base 10 equal to 4. Now we divide both sides by 2, then we get 1 upon 2 log 10,000 base 10 equal to 2 divided by 2 is 2, and I give this as equation number 2. Now from equation number 1 and equation number 2, as the right hand side is 2, therefore the left hand side must be equal. And what is left hand side? Left hand side is log 10,000 base 10 to the power 2 equal to 1 upon 2 log 10,000 base 10, and This is nothing else but the formula 1, log x base a to the power q equal to 1 upon q log x base a. I hope you have understood the numerical proof of the above formula. Now I erase this and we go to the next formula. We know that log x to the power n base a equal to n log x base a. Now in place of n we can write p also. So log x to the power p base a equal to p into log x base a, and we recently saw this formula number 1 from this page, which is log x base a to the power q equal to 1 upon q log x base a. Now if we mix these two formula, then we can write log x to the power p base a to the power q equal to p upon q log x base a. I hope you have understood the formula number 2. I erase this and we go to the formula number 3. Log 1 to any base equal to 0. Let a can be any number and a to the power 0 equal to 1. So from the definition of the log we can write log 1 base a equal to 0 as the power is 0. Here a is any number. So we can say that log 1 to any base a equal to 0. And the next formula is log a base a equal to 1. So we can write this a to the power 1 equal to a. And from the definition of log a base a equal to 1. Now we go to the last formula, and prior to that I erase this. 10 to the power 2 equal to 100. And from the definition of log 100 base 10 equal to 2. Here a equal to 10, x equal to 100. So a to the power log x base a equal to 10 to the power log 100 base 10. Now log 100 base 10 equal to 2. If we put that value, then what we get? 10 to the power 2 equal to 100 and 100 equal to x. So what we have proved? A to the power log x base a equal to x. I hope you have understood the numerical proof of the formula a to the power log x base a equal to x. Now we go to some important results which are useful for many competitive exams. Important, this I will request you to keep in mind. It will help you to solve the questions on logarithm in competitive exams and entrance tests. Part 1. A is greater than 1 and x is greater than 1. Then log x base a is greater than 0. And the example for it is 2 to the power 5 equal to 32. Here 2 is a, which is greater than 1. 32 is x, which is greater than 1. Then log 32 base 2 equal to 5. That is log x base a is greater than 0. Here 5 is greater than 0. Part 2. If a is in between 0 and 1, that is 0 is less than a is less than 1, or a is in between 0 and 1 and x is greater than 0, then log x base a is greater than 0. And the example is 0.5 raised to power 2. Here 0.5 is in between 0 and 1 equal to 0.25. 0.25 is greater than 0, that is x is greater than 0. Then log 0.25 base 0.5 equal to 2, that is x is greater than 0, here 2 is greater than 0. Part 3. If a is greater than 1 and x is in between 0 and 1, that is 0 is less than x is less than 1, then log x base a is less than 0. And the example is 10 to the power minus 3. Here 10 is greater than 1, that is a is greater than 1, equal to 0.001. Here 0.001 is in between 0 and 1, that is x is in between 0 and 1. Then log 0.001 base 10 equal to minus 3. Here log x base a is less than 0 and minus 3 is less than 0. So this way we can learn the important points. Now we go to the next topic, characteristic and mantissa. Point 2. A. Common logarithms. Logarithm to base 10 is called common logarithms. If base is not given, then it is assumed the base as 10. And part B, natural logarithms. Logarithm to base e, which is approximately equal to 2.71828 approx, is called natural logarithms. It is denoted by ln. Here it is ln, not in. Point 3. Characteristic and mantissa. Part A. Characteristic. When base of logarithms is 10, then exponential power is called characteristic. We learn it by the illustrations. 10 to the power 0 equal to 1. Here exponential power is 0. And this is going to be the characteristic when we take the log. This gives log 1 base 10 equal to 0. Here you see that 10 to the power 0 and characteristic is also 0. When the log of 1 is taken, then the characteristic 0. 10 to the power 1 equal to 10. This implies that log 10 base 10 equal to 1. Here the exponential power is 1 and characteristic is also 1. Then 10 to the power 2 equal to 100. This gives log 100 base 10 equal to 2. Here the exponential power is 2 and log of 100 is 2. 10 to the power 3 equal to 1000. So when we take the log of 1000, that is log of 1000 base 10 equal to 3. Here the exponential power is 3 and characteristic is also 3. Now one more thing you have to learn. When the number of digit is 1, then the power is, when the number of digit of log is 1, then characteristic is 1 less than the number of digits. Here the number of digit is 1, so the characteristic 0. In log 10, the number of digits of 10 are 2. Therefore, the characteristic is 1 less than 2, which is 1. In log 100, the number of digits of 100 is 3. Therefore, the characteristic is 1 less than 3, which is 2. In log 1000, the number of digits are 4. And characteristic is 1 less than 4, which is 3. Now, when the number is less than 1, for that we see the illustrations. 10 to the power 0 equal to 1, this we have already seen. This gives log 1 base 10 equal to 0. 10 to the power minus 1 equal to 0.1. This gives log 0.1 base 10 equal to minus 1, as the exponential power is minus 1. So the characteristic is minus 1, and minus 1 is also written as 1 bar. 10 to the power minus 2 equal to 0.01. This gives log 0.01 base 10 equal to minus 2. Here the exponential power of 10 is minus 2. Therefore the characteristic is minus 2. Minus 2 is also written as 2 bar. 10 to the power minus 3 equal to 0.001. Therefore log 0.001 base 10 equal to minus 3. Here the exponential power of 10 to the power is minus 3. Therefore the characteristic is also minus 3. And minus 3 is also written as 3 bar. Now important note. The characteristic of any number is 1 less than number of digits of the number when number is greater than 1, and when 0 is less than number is less than 1, the characteristic is negative, and 1 less than number of zeros after decimal point. Now I explain you. Here 10 to the power minus 1, then this is equal to 0.1. Here there is no 0 in between decimal point and 1. Therefore the characteristic is minus 1. In 10 to the power minus 2, which is equal to 0.01, here the number of 0 after the decimal point, the number of zeros are 1. This gives characteristic minus 2 because the number of zeros after the decimal point and the digit is 1. Therefore characteristic is minus 2, 1 less than number of zeros in between decimal point and the digit. In 10 to the power minus 3, this is 0.001. Here after the decimal point and digit there are 2 zeros. Therefore the characteristic will be 1 less than 2 zeros is minus 3. Is always negative, and 1 less than the number of zeros after the decimal point. So it is minus 3. I hope you have understood this important point. Now part B, mantissa. The decimal part of logarithm of any number is called mantissa. Logarithm of any number can be found from log table. Mantissa is always positive. It is always useful to memorize the value of log 2 and log 3. The value of log 2 is 0.3010 and log 3 is 0.4771. The topic logarithm is very easy, provided you try to understand it properly and solve the questions of logarithmics. In coming videos, we are going to solve many questions of logarithms. Please watch all my videos on quantitative aptitude topics. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.